The ground trembled first, not with the sharp, violent shudder of an earthquake, though the earth had been moving for millions of years in preparation for this moment. No, this trembling was something different, something slower, something that began as a whisper deep within the rock, a vibration so low and so vast that no creature alive in that ancient world could have perceived it as sound. It was felt, rather, in the bones of the land itself, in the limestone, in the salt, in the deep, cracked sediment of a basin that had been waiting, baking, silent and empty, for an eternity. And then the water came. Breathe in for a moment, if you will, and let yourself be carried back. Not centuries, not thousands of years, but millions of years into the past, to a world so alien in its geography that the continents themselves would be unrecognizable to any eye trained on a familiar map. Let your shoulders soften. Let the weight of the present moment drift away. Because what is about to unfold is one of the most staggering events in the 4.5 billion-year history of this planet. And it begins, as so many great things do, with a single crack. Somewhere in the narrow mountainous corridor where the Atlantic Ocean pressed against the western edge of what had once been a flourishing inland sea, the rock gave way. It did not give way all at once. The Earth is rarely so dramatic in its announcements. But a fracture had been deepening, slowly, over hundreds of thousands of years, weakened by the immense hydrostatic pressure of an ocean on one side, and the vast, hollow, desiccated emptiness of a dead basin on the other. And on a day, if one could call any point in deep geologic time a day, the threshold was crossed. It became a stream became a river became something for which there is no adequate word in any language that has ever been spoken. The water that poured through that breach in the rock did not pour. Pouring implies a gentleness, a controllability, a relationship between liquid and vessel that suggests some kind of proportion. What happened at the western end of the Mediterranean basin, at the place that would one day be called the Strait of Gibraltar, was something categorically different. The Atlantic Ocean, enormous and relentless, driven by the weight of its own incomprehensible mass, did not pour into the empty basin below. It fell. It fell from a height that staggers the imagination. The Mediterranean basin, at the moment of the breach, sat far below the level of the Atlantic, in some places nearly 3 kilometers below sea level. 3 kilometers. To put that depth into any meaningful frame, consider that the highest peaks of many great mountain ranges would be swallowed whole, their summits vanishing beneath the surface of what was about to become the sea. The basin was not merely low, it was a wound in the surface of the earth, a vast, sunken plain of salt and silence, baked by a sun that had no mercy. And into this wound the Atlantic fell. The waterfall, if one single word must be chosen to describe it, would have dwarfed anything else in the natural world. The cascade of seawater that thundered through the Strait of Gibraltar during those first hours and days of what geologists would come to call the Zanclean Flood was not a waterfall in any sense that the word has ever been used. It was a column of ocean, a moving wall of white and blue and green, roaring with a sound so immense that the concept of loudness becomes meaningless in its presence. The air itself would have been saturated with mist for hundreds of kilometers in every direction. The vibration of that falling water would have reverberated through the bedrock of 2 continents simultaneously. On the African side of the breach, the ancient limestone cliffs would have shaken. On the Iberian side, the rock would have groaned under the force of the current. And below, far, far below, where the water landed, where the Atlantic first touched the floor of the empty basin, the impact would have carved craters into the ancient salt flats, blasted through centuries of sedimentary crust, sent shock waves of displaced air rolling outward across the silent desert of the basin floor like an invisible tide preceding the real one. The sound of it would have been, to borrow a word from a scale of experience no living thing has ever survived, apocalyptic. But there was no one to hear it, no mind to register its enormity, only the bare rock, the crystalline salt, the scorched and silent earth, and now suddenly rushing toward them at speeds that no river has ever matched, a white wall of ocean. Stay with this image for a moment. Let it settle over you like the weight of deep time itself. A wall of water, roaring through a gap in the mountains, falling 3 kilometers into the bowl of an ancient Dead Sea, spreading outward across a basin the size of a continent, the air thick with salt spray, the earth trembling, and the silence of millions of years broken, finally, irrevocably, in a single geological instant. This is where our story reaches its crescendo. But to understand it fully, to feel the true weight of what that flood meant, what it completed, what it washed away and gave back, we must travel backward. We must go back not just thousands of years, but millions. We must find the moment when the Mediterranean Sea first began to disappear. And that story begins, as so many stories of deep time do, with the slow, imperceptible dance of continents. The Earth's surface has never been still. Even at its most apparently motionless, the crust of this planet is moving, grinding, sliding, colliding, drifting, driven by the enormous thermal convection currents that churn within the mantle far below. The continents, which appear so permanent and fixed on any map, are in truth wanderers, moving at speeds roughly comparable to the growth of a human fingernail, yet over millions of years traversing distances that dwarf any ocean voyage. And it was this slow, grinding movement of continents that set in motion the chain of events that would eventually drain one of the largest bodies of water on the face of the earth. To understand what happened, we must picture the Mediterranean not as it would eventually become, that warm, blue, tideless inland sea cradled between Europe, Africa, and Asia, but as its ancient ancestor, a far larger and more open ocean called the Tethys Sea. The Tethys was ancient even by geological standards, a broad tropical seaway that stretched from what would become the Atlantic all the way to what would become the Indian Ocean, separating the northern land masses from the southern ones. For hundreds of millions of years, the Tethys was one of the great defining features of the planet's surface, teeming with life, warm with tropical currents, vast beyond any reckoning. But the continents were moving. Africa was drifting northward. The Arabian Peninsula, still joined to Africa, was pushing into the soft underbelly of what would become Europe and Asia. And slowly, with a patience that makes human history look like a momentary flicker, the Tethys Sea was being squeezed. Its eastern passages were closing. Its connections to the wider ocean were narrowing. Mountain ranges were rising where ocean floor had once been. The Alps, the Himalayas, the ranges of the Middle East, all of them born from the collision of plates, all of them built from the compressed and crumpled remnants of ancient seabeds. By the time we arrive at the period geologists call the Miocene, roughly 20 million years ago, the Tethys had been reduced to a remnant of its former self. What remained was still large, still connected to the Atlantic in the west, still capable of sustaining an enormous and diverse community of marine life. This remnant is what we recognize as the ancient precursor to the Mediterranean. And for millions of years, it was a thriving sea, blue and warm, surrounded by landscapes that were beginning to resemble, in their broad outlines, the world we might recognize, though still without the mountains fully formed, without the familiar shapes of coastlines, without the particular configuration of islands and peninsulas that would define the later Mediterranean world. But the continents did not stop moving. Africa continued its slow northward push, and as it did, the western connection between this ancient Mediterranean and the Atlantic Ocean began very gradually to change. If you can, soften your breath a little now and follow this thread into deeper time. Let the image of those enormous, slow-moving continents settle into your mind like sediment drifting to the floor of a quiet sea. Because what happens next is a story of gradual isolation, of a great body of water slowly losing its connection to the wider ocean, drifting toward a fate that seems, from a human perspective, almost unimaginable. The connection between the ancient Mediterranean and the Atlantic was not a single passage. For much of the Miocene, there were actually two routes by which Atlantic waters could enter the Western Mediterranean. One running through what is now northern Morocco, across the terrain that would become the Rif Mountains, and another running through what is now southern Spain, through a corridor called the Baetic Seaway. Together, these two passages maintained the Mediterranean's connection to the global ocean, allowing the constant exchange of water that kept salinity levels stable, that replenished the sea's waters against evaporation, that sustained the rich and varied life within it. But these passages were in terrain that was being actively deformed by the collision of Africa and Europe. The same tectonic forces that were building the mountains of the Mediterranean region were slowly uplifting the land through which these seaways flowed. And beginning somewhere around 7 million years ago, the process of closure began in earnest. The Betic Seaway, running through southern Spain, was the first to go. The land it crossed was rising, not dramatically, not in any way that any creature living through it could perceive, but rising nonetheless, a few millimeters per century, decade after decade, millennium after millennium, until the shallow marine corridor that had once allowed ocean water to flow freely into the Mediterranean became a series of brackish lakes, then marshes, then dry land. Marine creatures that had once moved freely through this passage found themselves in waters growing increasingly isolated, increasingly salty, increasingly unlike the open ocean from which they had come. Some adapted. Most, over the long sweep of time, did not survive the transition. The northern passage through Morocco lasted a little longer, but it too was being uplifted, compressed, squeezed by the relentless northward pressure of the African plate. And sometime around 6 million years ago, the geological evidence, preserved in the rock and salt layers of the Mediterranean basin, points to a period beginning approximately 5.96 million years ago. The last significant surface connections between the Mediterranean and the Atlantic were severed. The Mediterranean Sea was alone. In the immediate aftermath of this isolation, the sea did not disappear. It was still an enormous body of water, stretching nearly 4,000 kilometers from west to east, fed by rivers draining from Europe and Africa, cooled by the same winds, warmed by the same sun. The marine life within it continued its ancient routines. The waves still broke on ancient shores. The sea still sparkled in the long Mediterranean afternoons. But something had changed, something fundamental, something that would, over the coming hundreds of thousands of years, transform this sea utterly. In any large body of water, there is a constant competition between the water coming in and the water going out. Water enters a sea through rivers, through rainfall, through connections with other bodies of water. Water leaves a sea primarily through evaporation, the sun's energy converting liquid water into vapor, lifting it into the atmosphere, carrying it away. In the open ocean, this balance is maintained by the constant exchange with the global ocean system. Salt levels remain relatively stable. The sea persists. But the Mediterranean, even when connected to the Atlantic, had always been a sea that evaporated more water than its rivers and rainfall could replace. The climate of the Mediterranean region, warm, sunny, seasonally dry, meant that the sun was always working harder to take water out of the sea than the natural hydrology of the surrounding land could put back in. The deficit had always been made up by the inflow of Atlantic water through the western passages. That Atlantic water, flowing eastward through what would become the Strait of Gibraltar, was the lifeline that kept the Mediterranean full. Now that lifeline was cut. The sun continued to beat down on the surface of the isolated sea. The winds continued to sweep across it, carrying evaporated water up into the atmosphere and away across the continents. But now there was nothing coming in to replace what was being lost. The rivers of Europe and Africa, the ancestors of the Rhone, the Nile, the Po, the Ebro, poured their waters into the sea as they always had. But the combined flow of all of them was not enough. It had never been enough. The Mediterranean was a sea that required the Atlantic to survive. And so the sea began, slowly and then, with gathering momentum, to shrink. Allow yourself to settle a little deeper into whatever stillness you have found, because what follows is a story told across hundreds of thousands of years. A story of slow loss, of withdrawal, of a sea retreating from itself like a tide that never returns. It is a story of extraordinary desolation, and it is also, in its strange way, a story of the Earth's capacity for transformation. In the early stages, the changes were almost imperceptible on any timescale that matters to living creatures. The sea level dropped by tens of meters, then hundreds of meters, over spans of thousands of years. Coastlines that had been underwater became exposed, first as shallows, then as mudflats, then as dry land. Islands that had previously been submerged became hills. The shallow continental shelves around the edges of the basin became broad, flat plains, first wet and marshy, then dry and salt-crusted as the water retreated further and further from the land. As the water level fell, the concentration of salt in the remaining water increased. The Mediterranean had always been slightly saltier than the Atlantic, but now with no dilution from incoming oceanic water and with evaporation relentlessly concentrating whatever remained, the salinity rose to levels that would be lethal to most marine life. The creatures that had flourished in the Mediterranean for millions of years, the fish, the invertebrates, the ancient cetaceans, the plankton that formed the base of the entire food web, found themselves in waters increasingly hostile to their existence. Some moved toward the river mouths where fresher water still flowed. Many, unable to adapt to the rising salt, simply died. And still the sea shrank. The geological evidence for what happened next is written in the rocks of the Mediterranean basin with extraordinary clarity. A clarity that would not be recognized and understood until geologists began in the 1960s and 70s to drill into the sediments of the deep basin floor and read what they found there. What they found was a layer, in places hundreds of meters thick, of evaporate minerals, salt, gypsum, anhydrite, the chemical residue of an evaporating sea precipitated out of the increasingly concentrated brine like crystals forming in a drying tide pool. These evaporate deposits are among the most telling geological records on Earth. They speak directly to the conditions under which they formed. Conditions of extreme evaporation, of brine so concentrated that minerals began to crystallize out of solution and sink to the floor, layer by layer, millennium after millennium, building up into vast beds of salt that today lie buried beneath the sediments of the modern Mediterranean floor. In places, these deposits are a kilometer or more thick. The sheer volume of salt preserved in these layers tells geologists something almost incomprehensible. At some point during this crisis, the Mediterranean was not merely shrunken or impoverished. It was effectively gone. The salt layers tell the story of progressive evaporation. First the less soluble minerals precipitating out, then the more soluble ones as the brine concentrated further and further. Calcium carbonate came first, settling to the floor in pale white layers. Then gypsum, a calcium sulfate mineral, crystallizing in broad, flat sheets. And finally, in the deepest and most remote parts of the basin, where the last remnants of brine collected and concentrated, halite, common salt, precipitating out in thick, white, blinding, crystalline beds. What the Mediterranean basin looked like at the height of this crisis, during what geologists would eventually name the Messinian Salinity Crisis, after the Messinian age of the Miocene epoch, is a question that is simultaneously straightforward to answer scientifically and almost impossible to fully comprehend imaginatively. Imagine, if you will, a basin roughly the size of the continental United States, but instead of a continent, it is a hole, a deep, sunken, bounded depression in the surface of the Earth, surrounded on all sides by mountain ranges and high plateaus, sitting in the full blaze of a subtropical sun. At its deepest points, where the water had been thickest, where the ancient seafloor lay furthest below what had once been the surface, the basin floor was 3, 4, even 5 kilometers below the level of the surrounding ocean, 5 kilometers below sea level, a depth so extreme that the pressure of the air above would have been significantly greater than anything felt at the surface of any ordinary landscape. And across this vast, sunken plain, silence. The silence of a place from which life has retreated, from which water has retreated, from which the future has retreated. A silence broken only by wind, and what wind it would have been. The exposed Mediterranean basin, sitting so far below the surrounding terrain, would have created its own atmospheric dynamics. Hot air superheated by the dark salt flats that absorbed and radiated the sun's energy with extraordinary efficiency would have risen in convective columns, drawing in cooler air from the surrounding highlands, creating persistent, fierce, dry winds that scoured the salt flats and lifted crystals of gypsum and halite into the air, filling the lower atmosphere of the basin with a perpetual white haze. The heat at the bottom of this basin would have been extraordinary. Already in the tropics to subtropics, the Mediterranean region receives intense solar radiation. But at the bottom of a basin 5 kilometers below the surrounding terrain, the air pressure would have been significantly elevated, compressing and warming the air column above the basin floor in a manner similar to what happens in any deep desert valley, but on a scale and to an extent that has no parallel in the world as we know it. Temperatures on the salt flats of the deepest parts of the ancient basin may have reached levels that make the hottest deserts of the world seem temperate by comparison. Breathe slowly now. Picture this vast, white, silent place. The salt flats stretching to horizons that are lost in the white haze. The air shimmering with heat. The occasional creak and crack of crystalline salt structures expanding and contracting with the daily cycle of temperatures. The wind, dry and relentless, sweeping across plains of gypsum that glitter with a cold, mineral light. No plants, no animals, no water. Only the earth and the sun and the ancient chemistry of an evaporated sea. But it was not entirely flat. The rivers had not stopped flowing simply because the sea had disappeared. The great rivers that drain the surrounding continents, the ancestors of those rivers that would one day be known as the Nile, the Rhone, the Po, the Ebro, continued to flow toward the basin, driven by gravity, following the paths they had always followed. And now, with no sea to flow into, with the basin floor dropping away thousands of meters below their former mouths, these rivers did something extraordinary. They cut down, they incised, they carved, through the rock and sediment and salt of the exposed margins of the basin, canyons of staggering depth. The ancestor of the Nile River, faced with a basin floor that had dropped nearly 3 kilometers below its old mouth, responded by eroding backward through its own valley, cutting a canyon through the soft limestone of what is now Egypt that geologists would eventually call the Aeonal Canyon, a trench comparable in scale to the Grand Canyon, now buried beneath the sediments of the modern Nile Delta. The Rhone, draining from the Alps into the western basin, carved a canyon through the landscape of what is now southern France that was deeper than any valley that exists in that landscape today. Its walls cut into the rock over hundreds of thousands of years of erosive work, now buried and invisible, but detectable to those who know how to read the subsurface. These canyons were the Earth's response to the crisis, the landscape adjusting, as it always does, to new conditions, rivers seeking their new base levels, the long, patient work of water on rock, proceeding even in the absence of the sea that had once been the river's destination. They are silent testimonies, these buried canyons, to the depth of the crisis, to how far the basin floor had sunk below the surrounding world, to how completely the Mediterranean had withdrawn from its ancient bed. And so time passed. Hundreds of thousands of years passed. The salt accumulated layer by layer. The canyons deepened, meter by meter. The basin baked in its own heat, and the world above, the plateaus and mountains surrounding the Mediterranean, continued its slow tectonic business, unaware, in any meaningful sense, of the extraordinary emptiness that lay below. Whether the Mediterranean basin was entirely devoid of water during the deepest phase of the Messinian Salinity Crisis is a question that scientists have debated with great care. The evidence suggests that the picture was complex, that in different parts of the basin, at different times, conditions varied considerably. In the deepest, most enclosed parts of the western and eastern basins, the evaporation may indeed have been virtually complete, leaving behind only the thick beds of salt and gypsum that geologists later found buried in the sediments. But in shallower areas, near river mouths, in isolated depressions that collected what little water remained, small and extremely saline lakes may have persisted. Bitter, hypersaline, perhaps studded with the strange crystalline formations that grow in ultra-concentrated brine, their shores encrusted with white mineral deposits, their waters hostile to almost all life. There is also evidence, preserved in the fine structure of the evaporate layers and in the organic material trapped within them, that the crisis was not necessarily a single, smooth, uninterrupted event. There may have been episodes driven by changes in climate or by brief, temporary reopenings of western connections, during which water returned to parts of the basin, refilling it partially, diluting the brine, allowing the brief return of life before the connections closed again and the cycle of evaporation resumed. The Earth does not deal in simple stories. Its history is layered and complex, full of interruptions and reversals, of brief reprieves followed by the resumption of longer trends. But the broad outline is clear. For a period of approximately 600,000 years, from roughly 5.96 million years ago to approximately 5.33 million years ago, the Mediterranean basin existed in a state of profound desiccation. The great sea that had been the heir to the Tethys, that had sustained millions of years of marine evolution, that had shaped the climates and landscapes of three continents, was gone, or very nearly gone. A wound in the surface of the earth, salt-floored, baking, silent, waiting as it turned out, with the patience of deep time, for the return of the water. Let yourself drift a little now, if you feel the pull of sleep beginning to find you. These stories are not going anywhere. The earth has kept them safe in its rocks for millions of years. They will be here when you return. And if you stay awake, what comes next is worth staying awake for. Because the return of the water to the Mediterranean is one of the most extraordinary acts in the geological history of this planet. The tectonic situation that had caused the crisis was not static. Nothing in the geology of this region was ever static. The African plate was still moving northward. The Iberian Peninsula, that broad, roughly square landmass that would one day be known as Spain and Portugal, was being subjected to its own complex set of tectonic stresses. And in the narrow zone between the Atlantic and the empty Mediterranean basin, the terrain was slowly, almost imperceptibly, changing. It is not entirely clear, and this remains a subject of active scientific investigation, exactly what finally allowed the Atlantic to breach the barrier between itself and the Mediterranean. The most widely accepted model suggests that the barrier was not simply a flat, static wall of rock, but rather a complex, actively deforming zone where the land was rising in some places and subsiding in others, where erosion was constantly reshaping the surface, where the hydrostatic pressure of the Atlantic, sitting several kilometers higher than the basin floor on the other side, was always pressing against whatever barrier remained. Over hundreds of thousands of years, the barrier eroded. Rivers flowing from the Atlantic side, the ancestral rivers of what would one day be called Andalusia, cut into the rock, working their way backward toward the Mediterranean side, their valleys deepening under the influence of the Atlantic's elevated base level. Groundwater seeped through fractures in the limestone, slowly dissolving the rock from within, creating pathways for fluid that over long timescales could become pathways for larger flows. The barrier became thinner, weaker, more permeable. The pressure on one side was enormous. The deficit on the other side was enormous. Only the rock stood between them. And then, approximately 5.33 million years ago, the date is constrained by the geological record with remarkable precision. The rock was no longer enough. We return now to where we began, to the moment of the breach, to the first crack, the first trickle, the first rush of Atlantic water into the dry throat of the ancient canyon that the barrier's rivers had carved. The initial flow may have been modest, a stream perhaps, finding its way through a new passage in the rock, spilling down the steep gradient on the Mediterranean side, falling toward a basin floor that was thousands of meters below. But as the water flowed, it eroded. And as it eroded, the passage widened. And as the passage widened, more water flowed. The feedback was rapid and self-reinforcing in a way that, in geological terms, was almost instantaneous. The models that scientists have constructed, based on the physics of water flow, on the geometry of the basin, on the evidence preserved in the rocks, suggest that the flooding of the Mediterranean may have proceeded at a rate that is almost beyond comprehension. Not over millions of years, not even over hundreds of thousands of years. The best estimates suggest that the Mediterranean basin, once the breach was established and the channel had widened to allow substantial flow, may have refilled within a period ranging from a few hundred years to perhaps 10,000 years. In geological time, that is not merely fast. It is essentially instantaneous. A flash, a breath, a single moment in the long dream of deep time. But in any meaningful experiential sense, it was a catastrophe of extraordinary duration and violence. Picture the breach in its early stages, perhaps days or weeks after the initial breakthrough. The channel through the rock is still narrow, perhaps only a few hundred meters wide, but already the gradient is so steep, the pressure so immense, that the water flowing through it is moving at speeds no river on Earth has ever matched. Not in any landscape that has existed within the memory of life. The water crashes through the gap in the rock and immediately enters freefall, plunging down the face of the ancient barrier in a cascade whose scale increases day by day as the channel widens. The erosion at the base of the falls, where the falling water strikes the floor of the ancient canyon, is itself a geological event of considerable power. The impact of that much water, falling that far, striking rock with that force, would excavate enormous plunge pools, blast away ancient sediment, carve new channels in the rock that in turn guide and accelerate the flow. The falling water, saturated with the energy of its descent, releases that energy explosively at the point of impact, and the canyon below the falls deepens and widens to accommodate it. Meanwhile, the flood spreads outward across the basin floor. In the earliest days, the water would have first encountered the deepest parts of the western basin, the ancient abyssal plains, now salt flats, now the receiving end of an ocean. The first water to arrive would have spread thinly across the salt, dissolving the surface layers, mixing with whatever residual brine remained in any low-lying depressions, creating a vast, shallow, increasingly deep body of water that expanded in every direction. The salt itself, those hundreds of meters of evaporate deposits laid down over hundreds of thousands of years, would have dissolved rapidly in contact with the incoming water. The chemistry of the refilling sea would have been extraordinary. A mixture of Atlantic seawater, dissolved ancient salt, minerals leached from the exposed basin floor, the concentrated residue of whatever rivers had been pouring their waters into the basin during the years of desiccation. It would not, in those early stages, have been anything like the clean, open ocean water that eventually filled the Mediterranean. It would have been chemically complex, turbulent, full of dissolved and suspended material, its color and clarity unlike anything in the ordinary ocean. As the basin filled, the rate of rise would have been remarkable. With a waterfall, or a series of increasingly large waterfalls as the breach widened, pouring the equivalent of ocean water into a closed basin, and with the basin's depth meaning that even a small volume of additional water produces a measurable rise in level, the sea may have risen by meters per day during the peak of the flood, by tens of meters per year as the breach widened toward its maximum extent. The shoreline, such as it was, constantly shifting as the water rose, would have moved inland by kilometers in the course of a single lifetime of any creature unfortunate or fortunate enough to exist in the region. The sound of the flood during its peak phase would have filled the entire basin. Sound travels far across open water, and the Mediterranean basin, even as it filled, was still mostly an enclosed space. The roar of the falls at the western end, the crash of the advancing water across the salt flats, the deep subsonic rumble of the eroding rock. All of it would have echoed from the surrounding walls of the basin, reflected and amplified in ways that no landscape in any later world would ever replicate. The basin would have been, in a real acoustic sense, full of sound, full of the voice of the Atlantic, speaking in the only language available to an ocean making its return. Rest easy now as this story continues to unfold in the deep chambers of your imagination. If you found a comfortable stillness, stay with it. And if you're still following this journey through time, you are doing something remarkable. You are holding in your mind a vision of an event so vast and so ancient that the human brain was never evolved to encompass it. And yet here you are, encompassing it anyway. That capacity for wonder is one of the most extraordinary things about the kind of mind that emerged, eventually, from the long story of life on this planet. The flood proceeded, week by week, month by month, year by year, decade by decade, century by century. As the water rose in the basin, it began to encounter the ancient landscapes that the long desiccation had created. The river canyons, those deep gorges carved by the ancestral Nile and Rhone, and the other great rivers of the region, began to fill from the bottom up. The deep trench that the ancestral Nile had cut through the limestone of what would one day be Egypt slowly became a narrow arm of the rising sea, its walls disappearing beneath the water as the level rose, its canyon becoming a fjord, then an estuary, then eventually disappearing entirely beneath the expanding Mediterranean. The same was true of the other river canyons, each of them gradually submerged as the great refilling continued. The shallow shelves and margins of the basin, which during the desiccation had been broad, flat salt plains, were drowned progressively. Salt beds that had accumulated over hundreds of thousands of years were dissolved by the advancing water. The margins of the basin, where the surrounding mountains descended to what had been the ancient shores, were transformed as the water rose, from dry slopes into shallow coastal waters, from shallow coastal waters into deeper sea. The geography of the basin changed dramatically and continuously throughout the flooding event, the outline of the sea shifting with every passing century as the water rose. And as the water rose, something else happened. Something slower and less dramatic than the thunderous advance of the flood itself, but in its own way equally significant. Life began to return. The Atlantic Ocean, through the breach at the western end of the basin, was not only sending water into the empty Mediterranean, it was also sending life. Marine organisms, the larvae of fish and invertebrates, the spores and cysts of various algae and microorganisms, the floating eggs of countless species, were carried through the growing strait along with the water. Many of them would not have survived the long journey through the turbulent, chemically unusual waters of the early flooding phase. The brine and the dissolved salt in the mineral-rich water of the newly refilling basin would have been challenging environments for organisms adapted to normal ocean conditions. But some survived. And with the resilience that life has always shown in the face of planetary-scale upheaval, the survivors began to establish themselves in the new waters of the gradually filling basin. In the shallower areas, in the calmer margins, where the water was less turbulent and the chemistry less extreme, pioneer communities of hardy marine organisms began to take hold. Not the rich, diverse communities that had characterized the Mediterranean before the crisis. That recovery would take much longer, would require the gradual normalization of the basin's chemistry and the re-establishment of stable ecological relationships. But a beginning, a first tentative reaching of life back into the space that the sea was reclaiming. The breach at the western end of the basin, the waterfall that had begun the whole extraordinary process, was itself changing throughout this time. As the water flowed through it, the channel widened. The soft rock on the sides of the breach was eroded by the immense force of the current, carved back meter by the sandblasting effect of water, carrying dissolved and suspended material at high velocity. What had begun as a narrow crack in the barrier became, over time, a broad channel. What had been a single towering waterfall became a series of falls, then rapids. Then as the channel widened and the elevation difference between the Atlantic and the rising Mediterranean decreased, eventually something closer to a fast-flowing strait. The widening of the breach was itself a positive feedback. A wider channel allowed more water to flow, which eroded the channel faster, which allowed even more water to flow. The system accelerated toward its equilibrium in a curve that was far steeper in the early and middle phases of the flooding than at the end, when the Mediterranean was approaching the level of the Atlantic and the driving pressure differential was diminishing. Eventually, and this eventually is measured in centuries to perhaps a few thousand years at the outside, the Mediterranean reached a level close to that of the Atlantic. The falls subsided, the rapids calmed. The extraordinary breach in the Western Barrier, now wide and deep, became the Strait of Gibraltar. Not yet named, not yet witnessed by any mind capable of naming it, but already recognizable in its broad geography as the narrow seaway that would one day connect Europe and Africa across a gap of barely 14 kilometers. The Mediterranean was back. Not the same Mediterranean that had existed before the crisis. Not yet. The water chemistry was still unusual. Saltier than the Atlantic in some areas, less salty near the major river mouths. Chemically complex in ways that would take hundreds of thousands of years to normalize fully. The distribution of life within the basin was sparse and uneven, concentrated near the strait where Atlantic species were most readily introduced, thinning out toward the eastern end of the basin, where the water had sat longest and changed most. The floor of the basin was changed, its ancient sediments disturbed by the flooding, its salt beds partially dissolved, its topography modified by the erosive work of the incoming water. But the sun was on the water again. The waves were running across a surface that had not been a sea surface for hundreds of thousands of years. The long silence of the desiccated basin was replaced by the sound of water. Wind-driven waves, the gentle surge of tides so subtle as to be almost imperceptible in a nearly enclosed basin. The voice of rivers entering from new mouths at new levels, finding their way to a sea that was once again there to receive them. And slowly, on geological timescales, slowly, the Mediterranean returned to something like what it had been. The marine life recolonized. The climate of the surrounding regions responded to the presence of the large water body, moderating, moistening, shifting in ways that the long desiccation had disrupted. The physical geography of the basin settled into the configuration that, with continued gradual modification, would persist through the coming millions of years. The Strait of Gibraltar, that wide scar in the western barrier left by the Zanclean Flood, remained open. The tectonic conditions that had allowed the western seaways to close in the first place had not fundamentally changed, and the possibility of future closure always lurked in the geological background. But for the period of time that matters to the history of life in the Mediterranean region, the strait remained open, a permanent, if ever shifting, connection between the Atlantic and the inland sea. The evaporate deposits laid down during the desiccation were buried beneath the sediments of the refilling sea, preserved in the dark depths of the basin floor, where they would remain for the next 5 million years, waiting to be discovered and interpreted by minds that had not yet evolved, that would not evolve for another several million years, that when they finally did evolve would spend centuries puzzling over the strange white mountains and salt formations that occasionally emerged from the ground of Mediterranean countries before finally, in the 20th century, developing the tools and the conceptual framework to understand what those formations meant. The Messinian Salinity Crisis left its mark on the world in ways both visible and invisible. The evaporate deposits are the most dramatic. Those vast underground fields of salt and gypsum, some of them meters thick, some of them kilometers below the surface of the modern sea, testifying to the completeness of the desiccation, to the extraordinary chemistry of an evaporating ocean. The buried canyons, the ghost valleys carved by rivers responding to the lowered base level, are another legacy, detectable now through geophysical techniques. Their depths filled with sediment, but their shapes preserved in the subsurface as silent witnesses to how far the basin floor had fallen. The biology of the Mediterranean carries the crisis in its own way, though the record is more complex and harder to read. The marine life of the modern Mediterranean is not a continuous lineage stretching back through the Messinian. The crisis was too severe, too complete in its effect on the marine environment, for simple continuity to survive. The modern Mediterranean's marine fauna is largely an Atlantic fauna that colonized the basin after the Zanclean refilling, modified by millions of years of subsequent evolution in a semi-enclosed environment. The ghost of the pre-crisis Mediterranean fauna persists only in the fossil record, in the organisms preserved in rocks formed before the crisis began, speaking to a rich and diverse community that was largely swept away by the Messinian. What do we make of this story? Not we, who live in a world shaped by this event in ways we may never fully trace, but simply, what is one to make of it as a story, as a chapter in the long history of a planet? Take a quiet breath with that question and let it settle. There is something humbling about the Messinian Salinity Crisis and the Zanclean Flood. Something that puts into perspective the ordinary categories of large and small, fast and slow, significant and insignificant. An entire ocean, not a river, not a lake, not a regional sea, but one of the great bodies of water on the face of the earth, evaporated, was lost, became a salt desert baking in a heat that no living thing could long endure, and then returned in a flood of such magnitude and velocity that by geological standards it was barely a moment in time. A snap of the fingers, a held breath, a single frame in a very long film. The scale of it resists the mind's attempts to hold it fully. 5 million years ago, 6 million years ago. Numbers that are easy to say and essentially impossible to feel. A basin the size of a continent, a waterfall kilometers high, centuries of flooding, the return of an ocean. And yet it happened. The evidence is there, written in the salt and the rock and the buried canyons with extraordinary clarity. The earth recorded it all faithfully in the only language it knows, the language of geology, of sediment and crystal and chemical composition, of layer upon layer of time compressed into the accessible archive of the subsurface. The earth kept the record, and eventually beings with curious minds and sensitive instruments came along and learned to read it. If you are still with this story, still here, in whatever quiet place you have made for yourself, still following this long journey through deep time, then something in you has responded to the scale of this event in a way that is worth recognizing. The human mind is not evolved for geological time. We think in days and seasons and lifetimes and generations. 5 million years is not a number we can truly feel, and yet we reach for it. We tell stories about it. We lie in the dark and we imagine the waterfall, the salt flats, the returning sea, and something in us responds. Some sense of proportion, of perspective, of the extraordinary privilege of being the kind of creature that can contemplate a story this old and this vast. If this kind of journey through the deep past is something that speaks to you, if the voice of geological time is one you find calming, or grounding, or simply wonderful in the oldest sense of that word, then consider staying close to these stories. There are so many more of them. The earth is full of them, written in every cliff face and riverbed and mountain range, in every fossil and crystal and ancient lava flow. Each one is a story of transformation, of change so vast and slow as to seem impossible, of the Earth's relentless capacity to become something other than what it was. The Zanclean Flood is, in many ways, the most cinematic of these geological stories. It has everything that a great drama requires: a buildup, a crisis, a moment of decision, a catastrophic resolution, and an aftermath that stretched across millions of years. But it is also, in its deepest nature, a story about return, about the persistence of balance, about the way in which the Earth, perturbed from its equilibrium by the long, slow forces of tectonics and climate, finds its way back, not to the same equilibrium, never to the exact same state, but to a new arrangement, a new stability, a new ocean filling an ancient bowl. The Mediterranean is back, has been back, in fact, for 5.33 million years, longer than the entire span of human evolution. Everything that happened there subsequently, the rise of distinctive ecosystems, the shaping of climates, the eventual emergence, on the shores of that sea, of the civilizations that invented writing and philosophy and law and mathematics and the arts, all of it rests on the foundation of the Zanclean Flood, on the water that fell through the breach in the rock and slowly, over those extraordinary centuries, rebuilt a sea. The waterfall at the western end of the basin, that initial cascade of Atlantic water falling into the empty Mediterranean, did not last long in geological terms. As the basin filled and the sea level inside approached that of the Atlantic outside, the height of the falls diminished. The torrential cascade became fast-moving rapids. The rapids became a swift current. The swift current became, eventually, the bi-directional flow of the modern Strait of Gibraltar, where Atlantic water flows in along the surface to replace what the Mediterranean loses to evaporation, and saltier, denser Mediterranean water flows out along the bottom in a slow, deep current that has been maintaining the balance of the inland sea for the past 5 million years. That exchange is still happening. At this very moment, wherever you are, that slow exchange of water is occurring at the strait, the inflow and the outflow, the balance maintained across a narrow seaway between two continents, the same balance that the Messinian Crisis disrupted so catastrophically and the Zanclean Flood so dramatically restored. The planet is always doing things on this scale, always has been. The Mediterranean crisis is simply one of the events recent enough and geologically accessible enough for us to have pieced together its story with something approaching completeness. Elsewhere in the geological record, older, more eroded, the evidence more fragmentary, there are other stories of comparable scale waiting to be fully understood. The Earth is not a static backdrop for the drama of life. It is itself the drama, constantly in motion, constantly transforming, its timescale so vast as to seem like stasis from the inside, but revealing when the long view is taken, a restless and extraordinary dynamism. Let this thought carry you now as this story draws toward its close. Let the image of the ancient Mediterranean settle into your mind like sediment settling to the floor of a deep, still sea. The salt flats, the terrible heat, the silence of a basin that had been an ocean and would be an ocean again. The crack in the rock at the western end, the first trickle of Atlantic water, the cascade that became a flood, the centuries of rising water, the gradual return of the sea to its ancient bed, the slow recolonization of life, the establishment of a new equilibrium, fragile and beautiful and destined to last, at least for now, at least for the geological moment we inhabit. For millions of years, these are the rhythms of the earth, vast, slow, indifferent to anything as brief as a human life or a human civilization, yet not indifferent in any cosmic sense, simply operating on timescales that make human categories of fast and slow, important and trivial, begin to dissolve. On the timescale of the Earth, the Mediterranean's crisis and recovery is almost nothing, a brief flicker in a 4.5 billion-year story. On the timescale of marine life, it was catastrophic and transformative. On the timescale of mountains and oceans, it is one event among many, neither exceptional nor ordinary, simply part of the long, complex, endlessly surprising story of a living planet. And that planet is still telling its story. Right now, beneath every ocean, within every mountain range, along every fault line and volcanic arc, the Earth is still writing the next chapter of a story that no being has ever read in full, that no being ever will. We catch glimpses. We read fragments. We hold up small pieces of the record to the light and try to understand what they are telling us about the whole. The Messinian Salinity Crisis and the Zanclean Flood are one such fragment, a particularly vivid and dramatic one, a piece of the record that lends itself to the kind of story that can be told in the dark, in a quiet voice, to minds relaxing their grip on the ordinary world and opening themselves to something larger. So let go, now, of the flood. Let the water settle. Let the ancient Mediterranean find its level, its new shorelines, its gradual recovery. Let the sound of the great waterfall at the western end of the basin fade, as the water level rises and the falls diminish, and finally, across centuries, fall silent, replaced by the quieter, steadier sound of a sea breathing in and out through the narrow strait that connects it to the wider world. That sound continues, will continue for a time beyond any useful reckoning into a future we cannot imagine. The Strait of Gibraltar is open. The water flows both ways. The balance holds. And somewhere in the thick sediments of the Mediterranean floor, buried under millions of years of marine snow, the constant gentle fall of microscopic shells and mineral particles that is the deep ocean's version of silence, the salt layers of the Messinian wait, undisturbed, compressed, complete, a perfect record of an event that happened once and will not happen again in quite the same way, preserved in the only archive that endures on these timescales, the archive of the Earth itself. Sleep well if sleep has found you, and if it hasn't yet, perhaps let your mind drift out across that ancient sea, the one that is back now, blue and warm and full of life, the one that has forgotten in the way that seas forget things, the long centuries of its absence. Let the waves move across it in the way they have moved for the last 5 million years, since the water returned. Let the sun on it be the same sun, more or less, that baked the salt flats of the empty basin and then watched over centuries as those flats disappeared beneath the returning ocean. The Earth has a long memory, and sometimes in the quiet before sleep, it is possible to feel the edge of it, the vast dark depth of geological time, pressing gently against the thin membrane of the present moment, reminding us without words that everything we know is built on layers we will never see, shaped by events we can barely imagine. Part of a story so much larger than any of its chapters that the only reasonable response is something between humility and wonder. The Mediterranean is there. It has always been there more or less in the long human memory. It was there when the first eyes that could appreciate beauty looked out over its blue water. It was there before that, before any such eyes existed, when it was filling with the Zanclean Flood and the great roar of the western falls was the only sound in that ancient basin. And it was gone before that, a salt desert, silent and terrible, for a span of time longer than the entire history of the human lineage. It came back. The water always comes back, given time enough. The earth finds its balance. The story continues. And so, for now, does the quiet.